Good morning, students. Today I am repeating the article 8.3 of potential energy of the system of 2-point charges. ये आर्टिकल अपन ने लिया था, लेकिन वो साउंड सिस्टम बराबर नहीं होने से आपको समझ में नहीं आ रहा था। कुछ लड़कों ने कांटेक्ट किया था कि वो आवाज़ बराबर नहीं है, तो समझता नहीं वो लोग आवाज़ कम होने से। तो इसलिए मैं रिपीट कर रहा है आर्टिकल 8.3 that is potential energy, and this article is very important. So that what is potential energy? Potential energy of a system is the amount of work done against the electrostatic forces to achieve a certain configuration of electric charges in a given system. It means that to achieve the configuration of electric charges in a given system means for the collection of electric charges in a given system, the amount of work is required against the electrostatic forces which is acting between the given charge in the system and the charge which we have to displace from one point to another point. This work done against the electrostatic forces to achieve a certain configuration of a given system, to achieve a certain configuration of electric charges in a given system, and is called as potential energy of the system. To understand this concept of potential energy of a given system, some student asked me that how potential energy of the system increases. For this purpose, we use general example, and mechanically we can understand the concept of potential energy. Every system or every body in the universe, there is storage of potential energy. There is storage of potential energy. So how much potential energy stored in a system or in any material body in nature? If we have to find, then we must change the position of the body or position of the system. And for changing the position of the system or position of the body, it requires work. Without any doing work, there is no changing the position or configuration of any system. In order to change the configuration or position of any system, we have to perform some work against opposing factor in that system. Now this is the electrostatic system. This is the electrostatic system. So against electrostatic forces, if we have to change the configuration, we have to change the position of a given system by bringing another charge in the given system. So this is the concept of potential energy. म्हणजे work done and the amount of work done against the electrostatic forces to achieve a certain configuration of charges in a given system. This work is stored as potential energy in that system, and we have to obtain expression for potential energy of a given system, and this is the electrostatic system. This concept we can clearly understand by using a simple example, and that is, this is the container. This container filled with 10 liter of water. 10 liter of water. This 10 liter of water in the container is the system. And this 10 liter of water in the container, there is storage of potential energy. Now we have to add 1 liter of water into 10 liter of water. So this 1 liter of water cannot be added easily in 10 liter of water. In order to increase the volume of given system, if we have to increase the volume of this water from 10 liter to 11 liter, for adding 1 liter of water into this 10 liter of water, we have to perform some work on this 1 liter of water, and this work which is required for 1 liter of water to add into 10 liter of water, we have to supply energy from outside to this 1 liter of water. So this energy which is required to be supplied to 1 liter of water, then 1 liter of water has to perform some work against the opposing factor. Means this energy of 1 liter of water will add into the energy of 10 liter of water, so that the energy of given system thereby increases. The change in potential energy of a given system by performing some work against the opposing factor between 10 liter and 1 liter. This is the concept. अभी 10 लीटर वाटर था, उसमें एनर्जी स्टोर, उसमें अपने को 1 लीटर वाटर 1 लीटर वाटर ऐड करना है, यानी 11 लीटर बनाना है इसका। तो इजीली वैसा बनेगा नहीं, वो ऐड करने के लिए अपने को एक 1 लीटर वाटर के ऊपर कुछ भी वर्क करना पड़ेगा। वो वर्क करने के लिए एनर्जी सप्लाई करना पड़ेगा। तो जो एनर्जी अपन सप्लाई करेंगे 1 लीटर वाटर को, वो एनर्जी का यूज वर्क में कन्वर्ट होगा, and this energy which is supplied to 1 liter of water, by this energy, this 1 liter of water performing some work, then the volume of given system increases from 10 liter to 1 liter, 10 liter to 11 liter. Now 11 liter of water, there is energy, there is storage of energy, and 10 liter of water, there is storage of some amount of energy. It means that energy is stored in the given system by adding 1 liter of water into 10 liter of water. By this energy, there is increasing and potential energy of this system. So this is the concept. Now, using this mechanical analogy in case of electrostatic system, for this purpose, we consider the source of electric charge plus Q is situated at point O, which produces electric field in the surrounding space. Let us consider the source of electric charge. Let us consider the source of electric charge capital Q is placed at point O, which produces electric field in the surrounding space. This charge is called as source of electric charge, and this electric charge produces electric field in the surrounding space. In that electric field, there is storage of some amount of electrostatic potential energy. Now, we have to find how much change in potential energy of the system. For this purpose, we consider a small charge Q0. Let a small charge Q0 be brought from point A to B at respective distances R1 and R2 from the point O. We have to move Q0 charge from A to B in the electric field of this Q charge. What happened? We cannot easily move Q0 charge from A to B, and in order to displace Q0 charge from A to B, we have to perform some work on this Q0 charge against the electrostatic process acting between Q and Q0 charge in displacing the Q0 charge from A to B. This total work done against the electrostatic process in displacing the Q0 charge from A to B is a measure of changing potential energy of the system. Now, to obtain the expression for potential energy or change in potential energy of a given system, we must find the amount of work done against the electrostatic process which is acting between this charge Q and charge Q0. This total work done against the electrostatic process is a measure of change in potential energy of the system in displacing the charge and small charge Q0 from A to B. Means we have to find the expression for delta U. For this purpose, we must find the amount of work done from A to B. To find the amount of work done from A to B on this Q0 charge, first we consider let Q0 charge is placed at point P is at distance R from the source charge Q at point O. Whatever. If we place Q0 charge at point P in the electric field of plus Q charge at point O, what happens? According to Coulomb, this Q charge repels this Q0 charge at point P with some force. And this force of repulsion acting on Q0 charge at point P due to Q charge is given by Fp is equal to Q into Q0 upon 4.70 R square. Clearly? First, we consider a small charge Q0 at point P is at distance R from this Q charge, source charge Q at point O. Then, by Coulomb's law in electrostatic, the force of repulsion Q charge repels this Q0 charge at point P with some force, and this force acting on Q0 charge at point P is given by P is equal to Q into Q0 upon 4.70 R square. The direction of this force at point P is away from the point P along this direction. It means that this Q0 charge at point P in the electric field of plus Q charge is acted upon and by this force. Means Q0 charge at point P is bound and to this force. इतना फोर्स इसके ऊपर एक्ट हो रहा है, ये अंदर नहीं आने देगा। एक क्यू चार्ज एक Q0 चार्ज को अंदर आने नहीं देगा। तो क्यू चार्ज एक Q0 चार्ज को क्या कर रहा, रिपेल कर रहा। रिपेल करने से एक Q0 चार्ज की टेंडेंसी क्या रहेगी, टू मूव अवे फ्रॉम द पॉइंट। बट we have to move this Q0 charge from P to P dash. What we have to do? We have to move this Q0 charge from P to P dash through a very small distance dr. What we have to do? We have to apply external force. Is of same magnitude to that of this force, but opposite in direction. This force is minus. Clear is? ये फोर्स इसको पकड़ के रख रहा है, ये फ्री नहीं है, लेकिन अपने को वो Q0 चार्ज को P to P dash लाना है। वो लाने के लिए अपने को जितने फोर्स से उसको पकड़ के रखा है वो फोर्स खत्म करना पड़ेगा। वो खत्म कैसा होगा, जब अपन एक्सटर्नल फोर्स अप्लाई करेंगे। If I remove this force of repulsion which is acting on Q0 charge at point P due to this Q charge by any means, then Q0 charge at point P and will remain free and start moving from P to P dash through a very small distance dr. It means that this applied external force does some work on this Q0 charge in displacing the Q0 charge through a very small distance dr. This work is very small. That is, this work done is given by, that is, du, work done is a measure of changing potential energy in a given system in displacing the Q0 charge to a very small distance dr. ये कंसेप्ट क्लियर होगा क्या, नहीं होगा, ध्यान में रखना। एक पी पॉइंट अपन ने इलेक्ट्रिक फील्ड में कंसीडर किया, क्यू कितने डिस्टेंस पे, आर डिस्टेंस। तो बाय कूलम्ब्स लॉ इन इलेक्ट्रोस्टैटिक उसके ऊपर एक फोर्स एक्ट होगा क्योंकि उसके फील्ड में है। व्हेन वी प्लेस Q0 चार्ज इन द इलेक्ट्रिक फील्ड ऑफ प्लस Q चार्ज is at distance r from the point O, then according to Coulomb, this much force of repulsion acting on Q0 charge at point P, so that Q0 charge at point P has a tendency to move away from the point P. But we have to move this Q0 charge from P to P dash through a very small distance dr. So that we have to apply external force is of same magnitude to that of this force but opposite direction. This applied external force is given by minus Fe into dr. अभी ये एग्जाम्पल मैंने दिया था, 1 लीटर पानी इसमें 10 लीटर में ऐड करना है अपने को, वैसा इजीली ऐड नहीं होगा। अपन बोलेंगे 1 लीटर पानी इसमें डालना है अपने को, तो अपन ऐसा थोड़ी बोलेंगे। 1 लीटर पानी ऐड होगा इसमें, इजीली ऐड नहीं होगा, तो उसके ऊपर अपने को वर्क करना पड़ेगा ऐड करने के लिए। तभी ये 3 लीटर की एनर्जी थी पहले, 1 लीटर ऐड करने के बाद ये 11 लीटर बनेगा, 11 लीटर की एनर्जी तैयार होगी वहां। इट मींस दैट दिस इज द सिस्टम, इन दिस सिस्टम देयर इज इंक्रीजिंग पोटेंशियल एनर्जी by adding 1 liter of water. But this 1 liter of water consists of large number of milliliters, such as 1 liter is equal to 1000 ml. अभी 1000 ml is equal to 1 liter, 1 liter वाटर अपने को ऐड करना है 10 लीटर में, तो कितनी एनर्जी इसकी बढ़ेगी वो निकालना है। वो निकालने के लिए अपन ने ऑन स्टैटिस्टिकल पॉइंट ऑफ व्यू वी कंसीडर दिस 1 लीटर ऑफ वाटर इज इक्वल टू 1000 ml। अभी उस 1000 ml में से 1 ml इसमें डालेंगे, तो 1 ml डालने के लिए अपने को वर्क करना पड़ेगा 1 ml के ऊपर इस मात्रा, सेकंड ml मिलीलीटर डालना है और उतना वर्क करना पड़ेगा। इन दिस वे दिस 1 liter of water consists of such type of 1000 ml, so that 1000 times we have to perform the work on this 1 liter of water। अब ये 1000 ml, इसमें से 1 ml कंसीडर किया आपने, अपन ने 1 ml का बहुत सारे रीडिंग है, 1 ml 1 milliliter of water again and contains large number of milliliter, 0.1 milliliter, 0.001 milliliter, so on। तो उसमें से एक रीडिंग एक 0.001 ml डालने के लिए अपने को वर्क करना पड़ेगा। वैसे 1 लीटर में जितने 0.001 जैसे रीडिंग होंगे, जितने रीडिंग होंगे उतने वर्क अपने को करना पड़ेगा। जब हाउ मच टोटल वर्क इज रिक्वायर्ड टू इंक्रीज द वॉल्यूम ऑफ दिस गिवन सिस्टम फ्रॉम 10 लीटर टू 11 लीटर। By this work there is increasing potential energy of the given system. This is the concept. Using this concept, in this case, we consider a small charge Q0 at point P is at distance R from the charge Q in the electric field of the source charge Q. What happens? The force of repulsion F is acting on Q0 charge at point P due to this Q charge and is given by F is equal to Q into Q0 4 pi epsilon 0 R square. The direction of this force and is outward direction. Now we have to move this Q0 charge from P to P dash in this direction through a very small distance dr. For the displacement dr, we have to perform some work on this Q0 charge. This work done by the applied external force in displacing the Q0 charge from P to P dash is given by du is equal to minus F into Pr, because we have to apply external force is of same magnitude to that of this force for the positive direction, then Q0 charge and start displacing from P to P dash to a very small distance Pr. It means that this minus F applied external force does some work on this Q0 charge in displacing the Q0 charge from P to P as a very small distance. This work is a measure of increasing potential energy of the system for the displacement dr and is given by du is equal to minus ft into dr. Here this is the small one. म्हणजे for the displacement, small displacement dr, we have to perform this much work against this force of repulsion. Then q0 charge moves from P to P dash through this small distance dr. But our aim is we have to move q0 charge from A to B at respective distances r1 and r2 from the point O. They require such type of large number of them. यहाँ से यहाँ तक का है वो दिया डिस्कस एक बार कितना वर्क करना है, यहाँ से यहाँ तक का है कितना वर्क करना है, यहाँ से यहाँ तक का है कितना वर्क इतना वर्क मतलब between A and B we have to perform such type of large number of small work. And out of this large number of small work, one of the small work which is required for the displacement dr is how much? This. Therefore, how much total work is required against the electrostatic forces between A and B due to Q charge in displacing the Q0 charge from A to B is given by the sum of such type of large number of work from A to B and can be obtained by taking integration. If I integrate this small work from R1 to R2, and the total work done against the electrostatic forces in displacing a small charge Q0 from A to B is a measure of increasing potential energy of the system or is a measure of change in potential energy of the system for the displacement of Q0 charge from R1 to R2. And can be obtained by the integration, so that we can integrate this small part du, that is this is W AB is equal to R1 to R2 into du is equal to integration of R1 to R2 du is minus FE into dr is equal to R1 to R2 FD is equal to, that is minus Q1 to Q0 upon 4 pi epsilon 0 R square into dr. This is recalled as delta U, total change in potential energy of the system in displacing the Q0 charge from this is delta U is equal to, this is now after solving this integration is equal to minus Q into Q0 upon 4 pi epsilon 0 R square epsilon 0 integration of R1 to R2 to dr upon R square or is equal to delta U is equal to minus Q into Q0 upon 4 pi integration of R1 to R2 R to the power minus 2 dr is equal to